Hello and welcome. My name is Elhelw. Today I will continue the conversation about window functions, which we have started in the previous video. We introduced the concept of window functions. We introduced a bunch of different types of window functions like aggregate window functions, ranking functions, lead, lag, and so on. And as we have said last time, window functions can sometimes be called analytical functions because they are usually used in some of the common analytical queries. If you haven't watched the previous video, please, I recommend watching it before continuing with this one because we build on the knowledge that we had last time. I'm going to link the video in the description as well as up on the screen, so please make sure that you watch it first. To recap quickly what we've talked about, so the syntax of window functions is written like this. We start with the function name and then the arguments if it has any, and then the most important thing is to specify the over clause. The over clause tells the system that this is a window function. Whether this applies to aggregate functions or other functions, you have to specify the over clause because this is how the system knows that this is a window function. If the over clause is empty, then this means that we are going to operate on the whole table as a single entity or as a single partition. But you could also specify a partition by clause inside the over clause, which tells the query engine that we're going to split the table into different partitions based on the column that we are partitioning by here. So in this case, you have different partitions inside the table, and the window functions is applied on each of these partitions separately. You can also specify order by, again with some column, which now dictates the order in which the window function is evaluated, the order of the rows, so which order we're going to be visiting these rows and applying the window function. Let's see an example together. Let me just start by showing the table that we're going to be working with. So select star from employees. And if I run this query, so this is the employees table. We have the ID column, name, department, salary, and hire date for each employee, and we have 25 rows. Now, suppose that I want to, for every row, I want to display also the sum of the salaries in the department in which this employee works. So like, for Bob works in the security department, I want to also display the sum of the salaries in the security department. We saw examples like that in the previous video, so I will use the window function in this case. So let me rewrite the query. I am going to display name, department, salary, hire date, and also we want the sum of the salaries. We want that to be by each department. So first I have to specify the over clause since this is going to be a window function. And then since we want to partition them by department, I have to specify partition by department. And let me give this an alias. So I'm going to call it sum salary. So if I run this query, we get the results that we're looking for. So here for each employee in the engineering department, for example, we have the sum of all the salaries in the engineering department displayed with each row. The same thing for the HR department. We have the sum of the salaries here, also returned with every row. Same thing for the IT department, and so on. So this computes the sum of the salary within each of these partitions and prints it out with every row. We also saw that we could use order by inside the over clause. So I could add order by hire date, for example, and then run this query. Now the results are different. We don't get the same value for every row within the partition. And we've seen something like that last time as well. And we said that when we specify order by with the aggregate window functions, it changes the behavior. It starts acting more like a running aggregate rather than aggregating everything and having the same result for every row. So if you look at the HR department, for example, the first value is thus just the sum of that first salary. It's basically, you can think of it this way. When we're computing this function, we only have access to that first row. When we're computing this function, we can see those two rows. When we compute the third one, we can see those three. If you notice in the first department, this value doesn't really follow the rule that we're just saying. It's not really the sum of those three. So there's something else going on here. We'll explain that in a bit, but just for now, assume that it's more like a running sum. So as we've seen in the examples, the behavior of the window functions can be a little different depending on how you specify it. So if we look at a table like this, again, just a conceptual way of how things work, let's say we have this window function, we say partition by some column. Now, specifying this partition by ends in splitting the table into various partitions, again, depending on the values in that partition by column. And now we operate on each partition separately. So what happens is that the window function is applied on the whole partition, and we get the results with every row in that partition. This changes if we add order by, as we have seen in the example. In this case, we don't always get the same result with every row within the partition, because the subset of the rows that we're applying the function on can change given which row we're currently looking at. So for example, this subset could be just the first row or more rows and so on. Usually in the context of window functions, this group of rows that we are currently looking at, or that we're currently applying the function on, this is referred to as the frame. This is a very important concept in window functions. And like I said, once we have that concept, it means that it gives us more control over how the function is applied. So for example, you could be applying, when you're visiting the first row, you could be applying the function only on the first row. When you're going to the second row, you might be applying it on 2 rows. So now the frame has expanded. It could continue expanding with every row that you're visiting. That's why we've seen this behavior that looks like a running aggregate or a running sum, because the frame keeps increasing with the rows that we're visiting. So the value that we get from the function is different based on which row we are at, because the frame is changing. However, I also want to note that the frame doesn't always change in this way. It doesn't always just expand, right? Like, it could change in different ways. For example, the frame could change like this. It could start from the beginning, expand a little bit, and then move. So basically like excluding some of the earlier rows and including some new rows, and then start shrinking again. So the frame could move or expand or change in many different ways depending on how it is specified. Of course, so far we have not really specified the frame. So there is a default frame, which we will mention a little bit later, which is usually used if we don't specify anything concrete or specific, but we can explicitly specify how the frame is defined and how it changes if we want to have that more control. So in order to specify the frame explicitly, we can use one or two ways. Either use the rows keyword or use the range keyword. Each of them defines the frame in a different way. Both, basically, you need to specify the beginning and the end of the frame, but that beginning and end is specified differently depending on which of these ways we're using. So we're going to explain both of them. Let's start with the rows keyword. The rows keyword is used, again, like I said, to specify the beginning and the ending of the frame and how it changes, relative to the current row. So the current row, as a concept, this is the row that we are, let's say, visiting at any given point. We're processing all the rows in the partition, right? So we're trying to compute the window function for the first row, for the second row, for the third row. And the row that we are trying to compute the window function for, this is the current row at any given point in time. So the frame is defined relative to that current row. So if we're using the rows keywords, we try to define the frame relative to number of rows before and after that current row. The syntax looks like this. You say rows between frame start and frame end. Frame start and frame end have different options to specify there. So frame start could be unbounded preceding, end preceding, or current row. This means what? If you specify unbounded preceding, then the frame starts unlimited number of rows before the current row, which means it starts at the beginning of the partition. If we're not partitioning, then it's at the beginning of the table. But generally speaking, it's the beginning of the current partition. If you say n preceding, and n is a number, this means only includes the n rows before the current row. So if you say 5 preceding or 10 preceding or so on, this means only include the 5 rows or the 10 rows that are before the current row, not everything, only those n rows. If you say the current row, this means that the frame starts at the current row, so anything before that is not included. Similarly, with the frame end, you could say unbounded following, end following, or current row as well. So unbounded following means everything after the current row is included. If you say end following, it means only n rows after the current row are included. If you say current row, it means that current row is the end of the frame and nothing after that is included. So this is how we define the beginning and the end of the frame. So relative to the current row, this means that the frame could grow, it could shrink, it could move with us, and only the rows that are included in the frame, these are the ones where we apply the window function, and this is how we get potentially different results as we move along. So some examples of these different combinations, you could say, rows between unbounded preceding and current row. So this means that the frame starts always at the beginning of the partition and ends at the current row. So it means that the frame just keeps expanding as we're moving. You could also say between 2 preceding and 2 following, or 10 preceding and 7 following. It doesn't have to be the same number. So this means that the frame is going to include some rows before and some rows after the current row, and that keeps moving as the current row keeps changing. You could say between unbounded preceding and unbounded following. This means that the frame is always the entire partition. So this is the case where basically all the rows will get the same result because the frame here is not changing. You could say between current row and one following. This means that the frame only includes the current row and the row after that. So again, this keeps moving. You could say between current row and current row. This means that the frame is basically just the current row. So the function will only apply on this one row and will produce a result based on that. Of course, there are many different ways to combine these options, so just you can play with it and see how that affects the output of the window functions. So now that we know what a frame is, this explains what's happening here, because when we're computing each one of these, we're using basically the default frame. We haven't gotten into the default frame yet, but if I want to specify that I want to compute the sum over the entire partition and not just a running sum like I have here, so we can specify the frame that we want to run on. So we can use the rows keyword like we've just seen. So I can say rows between, and if I want this to apply on the entire partition, so the starting point is going to be unbounded preceding and the endpoint is going to be unbounded following. So this basically tells it that when you're computing the window function for any given row, your frame is going to be from the beginning of the partition until the end of the partition. So you apply it on the whole thing. So if I run this query, now we can see that we're back to the beginning where all the rows have the same result, which is the sum of all the salaries in that partition, because the frame is now the whole partition. It doesn't change with every row. We can play a little bit with this and specify different frames and see how that changes the answer. So if I say instead of unbounded preceding, unbounded following, I'm going to say 1 preceding and 1 following. So basically the frame is now moving with us. The frame is from one row before until one row after the current row, which I'm trying to compute the value of the function for. So let's run this query. So now we can see, if we look at the second row, for example, this 9700 is the result of adding up these 3 values. So the current row plus 1 before plus 1 after will give us this value. If we are looking at Alice here, this 10,500, again, it's the result of adding up these 3 values, which is again from 1 before until 1 after. Of course, there are some corner cases if we are looking at the beginning or the end of the partition. So here, for example, this is the engineering partition, right? So the last row is math. When I'm computing this value, there's nothing after it inside the partition. So, and like we agreed, when we're working with partitions, we don't look at the other partitions. So here I can only sum up these 2. So the current row plus 1 before. Same thing in the beginning. For Sam, there's nothing before that row, so I can only sum up the current row plus the one after. So again, these are things to keep in mind when you're using frames so that you understand what the results are going to look like. Let's change it a little bit more, and let's say I put here current row. So now I'm telling it that the frame is from one row before until the current row. So basically only sum up the current row and the one before that. So again, let's run this query and we can see the results change. Of course, for the first row, since there is nothing before it, then the sum here is just the value in the current row. For the second row, I'm summing up these 2 values. For the third row, I'm summing up these 2 values. For the fourth, I'm summing up these 2 values, and so on. So you can play with the boundaries of the frame as much as you want and see how that changes the results and understand how that changes. You can use unbounded, preceding or following. You can use like a specific number of rows. You can say current row. So there's lots of different options that you can use. Okay, let's move on to the range keyword and see how that differs from the rows keyword. So remember, when we were defining the frame using rows, we specified the number of rows before and after the current row. When we're using range, we're not really looking at the number of rows, we're looking at the value of the order by column. So the value of the order by column in the current row, this is how we specify how the range looks like. So we're looking at the values before and after this value in the current row. What does that mean? It's a little bit confusing, I know. So the syntax looks exactly the same, except we're using the word range instead of the word rows. And it also takes the exact same options as before, but in the context of range, these options mean something slightly different. Unbounded preceding and unbounded following, they mean exactly the same. They start from the beginning of the partition or the end at the end of the partition. So those are exactly the same as before. End preceding, end following, and current row, they mean something slightly different. So again, now we're working with values rather than with number of rows, right? What does that mean? Let's look at an example or more detailed explanation of those three. Suppose that we have this window function specification, right? We have over, partition by something, order by, let's say we have a field called quantity and we're ordering by that quantity, right? And then we specify a range between frame start and frame end. You can think of that as a condition that says quantity between some start value and end value. So any rows that have this condition satisfied are within the frame, right? So what is the start value and the end value? Suppose, again, like this is defined in relation to the current row, right? In the current row, suppose the quantity value, the quantity here is the column that we're ordering by. Suppose the quantity value has, is x, some value x, right? So if you specify the current row option in, either in the frame start or end, this is referring to that value x. If you are specifying n preceding, this doesn't mean n rows before, like we had in the rows keyword. Now, no, this means n values before x. If x is an integer, as in quantity here, for example, then this means that the start of the frame is x minus n. So let's say the current row has quantity 500, right? And you say n preceding, you say 50 preceding. So 50 here doesn't mean 50 rows. It says where the quantity is 50 before the current quantity, which is 500. So 50 before 500 is 450. So basically we're saying that the frame starts at 450, it ends at 500. So any rows that have quantity within that range are in the frame. Does that make sense? I hope so. And the same thing applies to following, of course, except here it's plus n. So again, if the current row has quantity as 500 and you say the n following is 100 following, so this means that anything between 500 and 600 is included. So this is basically how we define this. Let's take an example again to solidify this understanding and see how it works. Suppose this is the quantity column that we have and it's ordered, and this is the partition that we're working with. Now let's say we specified the frame as range between 30 preceding and current row. Again, this translates into the condition quantity between x minus 30 and x. X minus 30 because we said 30 preceding, and x because we said current row. So anything between these two values is included with us. So when we are processing the rows in that partition, row by row, we have to recompute this frame, right? So let's say, I'm going to skip that 387, but let's say we're looking at the 415. We're looking at this row, right? We're trying to compute the window function for this row. So the quantity value here is 415. So this means that the frame is all the rows that contain quantity between 385 and 415. So these two rows are the frame. So now I can apply the window function on these two rows, compute the result, and attach the result to the current row. Now I move to the next row. The next row has quantity equals 420. So then the window becomes, or the frame becomes between 390 until 420. And notice that this includes even the next row because it has a value of 420, which is included in the range that I specified. So this is how the frame is defined in this case. Now, when we move to the next row has the same value. So basically the frame is the same, doesn't change. I will still apply the window function on that same frame and produce a result for this row. When I move to the next row, now it changes, so the frame changes to 472 to 502, which includes just this single row. So we've seen with this range specification, the frame can change size, it can grow, it can shrink, it can move. A lot of different things can happen because it's not based on number of rows, it's based on the values in the order by column. One thing to note in this example, so far quantity was ordered in ascending order, right? So from the smallest to the largest. What if I specify here descending? This means that the quantity column will look like this. So the largest value is going to be first, the smallest value is going to be last. Then when you say n preceding, it means n values before the current value. Before here is not minus, before here is plus, because the larger values are first, right? So the more that you go before the current row, you're going to the larger value, so you need to add. The more you go after the current row, the smaller values you see, so you need to subtract. So when you use descending order, the plus and minus are reversed, so you need to keep that in mind, because otherwise you could get into some confusing situations. Earlier, I said that we have a default frame that we use if we do not specify it explicitly. So now that we understand the different kinds of defining the frames, the default frame is actually this one, range between unbounded preceding and current row. So if you don't specify any frame specifications, this is what the system is using. So this is why we get this behavior that looks like a running aggregation, but not entirely. This means basically that the frame starts at the beginning of the partition, because we said unbounded preceding, and it ends at all the rows that have the same value as the current row. And this is similar to what we've seen in the previous example. It might include rows after the current row if they happen to have that same value. So this is why it doesn't always give us that, running average, because when you have duplicates, things start to look a little bit different. Okay, let's see how we can demonstrate the range keyword. So let me actually copy this function here and put it as another window function. I'm going to call this sum salary 2. Let me put a comma here. And then I'm going to change this to use range instead of rows. Now, here, if I left it as it is, when I say one preceding, as we said, in range, I don't specify the number of rows. I need to specify a value or a range based on the type of the column used in the order by. So order by here is a higher date. So I want to specify a range that says, what the frame should look like in relation to that, the higher date value in the current row. So since I'm working with dates, the range has to be number of days or number of months or years and so on. So here, instead of 1, I'm going to write interval 90 day. This is the syntax for Postgres. It might be slightly different for other database systems, but basically what I'm saying here is that I want my frame to start at 90 days before the value, the higher date value in the current row, and ends at the value in the current row. So anything between the current row and 90 days before is going to be part of that frame. So let me run this query. This is the result. So we added this new column. We can see that for these 2 rows, for example, the first one doesn't have anything before it, so obviously it has to match the value here. The second one has a 1 value before, but this one is a lot further than 90 days, so it's not going to be part of the sum. When we look at, for example, Charles here, no, not Charles. Let me look at Henry. So Henry here is at August 31st. Jack in the same department is less than 90 days apart. So when we are computing the value here, we're going to include both of these because it's within the 90-day window that I specified. If we look at something like here, for example, those 2 have the same value, right? So it's within the 90-day period for sure. So when I'm computing any of them, it's going to be the sum of both. So this is how specifying the interval can result in computing the window functions. Let me try to show something else. Let me replace all the boundaries actually with current row. So if I replace this with current row, and I also replace this one here with current row. So I'm saying that the frame should start and end at the current row, right? Of course, this means something different when you use rows versus when we use range. When I use rows, it means that literally the frame starts and ends at the current row, so the frame is just the current row. But with range, it's not about the row, it's about the value in the current row, the value of the higher date in the current row. So what I'm saying is that take that value, and the frame should be all the rows that have that same value. So when we run this query, we're going to see the difference. So let's look first at the first column. So again, since the frame is just a single row, all the values here are going to be matching exactly the values here because each sum is literally the sum of that one value in the salary column. This is also the case for most of the columns here, except when we have duplicates. So if there is no duplicate, it's going to be exactly the same. So you see, this one is exactly the same. This one is exactly the same. These two are different. Why? Because again, like imagine how this works. We're trying to compute this value. So this is in sum sal 2, which uses range. So range says between current row and current row. So okay, what is the date value in the current row? This is the value. Who else has this value? This one also has the same value. So this is our frame, is these two rows. So now the sum applies on these two. So we get the sum of these two values here. And the same is also for here because it has the same frame. So you get that same sum in both rows. And the same applies here as well. You can see those three values in the sales department. They all have the same hire date. So this is the frame for them. And each of them is the sum of those three values. So let's go back to demonstrate the default frame, right? We've talked about that a little bit earlier. So I'm going to remove the frame definition from this one, and I'm going to comment out the second function just for now. Let's remove this comma. So let me run this query. So this is basically the same example that we've seen in the beginning, where we partition by department and order by hire date, and we've seen this thing that looks like a running sum, but not exactly. So this is using the default frame. So the default frame is, I'm just going to write it here without commenting this out. So the default frame starts from the beginning of the partition, so unbounded preceding, and ends at the current row, and it uses range. So if I comment this one out, if I remove the comment and run this query, you'll see that both columns are exactly the same. So this is the default frame. If I don't specify anything, as in the first case, this is what it uses. It automatically applies this. That's why we get the same values here. So what does this mean? It means that the default frame always starts from the beginning of the partition and ends at the value in the current row. So for the second row, the default frame is, or the frame is these two rows. For the third row, so this is the value that we have, and this value also appears in the fourth row. So the frame is these four rows. So that's why we get the 12,700 in the third row, and we also get it in the fourth row because it's the same frame. So keep that in mind. Again, if you don't specify a frame, this is the default one that gets used. All right, so let's summarize what we talked about today. Today, we continued the topic of window functions. We introduced the concept of frames as a way to have finer control over how the window functions are applied within the partition. We mentioned the different ways of specifying the frame using the rows keyword or the range keyword, and we've seen the difference in behavior between those two and the difference in the meaning of the options that we have. We've also seen what the default frame looks like if we don't specify explicitly, and we've looked at some examples in the demos today that illustrate that. I may or may not have another video on window functions, but for now, I hope that this has been clear so far. And if there's any questions or comments, please let me know and I will try to get to them as soon as possible. If you found this video useful, please hit the like button. Also, please subscribe to the channel if you haven't done so already. And with that, thank you so much for watching, and I will see you in the next video.